You're going.
All right. So at some point in your life, you've probably heard the term global warming. In fact, you're probably thinking about it now, since it's November and it's still 80 degrees outside. In which case, if you know anything about global warming or climate change, you probably know that greenhouse gases contribute to this problem. According to the Environmental Protection Agency, methane is the second most abundant greenhouse gas produced in the United States. Some common sources of methane pollution are agriculture, waste sites, and natural gas. Since methane traps heat more effectively than the most prevalent greenhouse gas, carbon dioxide, it's estimated to be 25 times more detrimental to the environment. Now, methane is actually made by microorganisms called methanogens. They live in your gut, the guts of livestock, as well as in marshlands. There are 3 different ways that methanogens can go about making methane, as you can see on the 3 pathways here. The portion where the pathways all connect is catalyzed by a coronoid cofactor. This cofactor is present in many different metabolisms, such as dechlorination as well as methanogenesis. Methanogens actually have the ability to put 2 pieces of the coronoid together. So the main coronoid structure is seen in white, and the second piece of the coronoid that can be different in different coronoid cofactors is called the lower base. And like I said before, methanogens have the ability to put these 2 pieces together, while other bacteria or archaea have to pick up and put together whatever they have in the environment around them. DeVolk is one of these scavenging bacteria. It can't make its own coronoids. Previous research from my lab shows that changing the lower base in the coronoid protein directly affects how fast DeVolk is able to dechlorinate a compound. Basically meaning that changing the lower base structure of the coronoid cofactor has a direct impact on the speed of the pathway. There's a similar coronoid-controlled step in methanogenesis, which is why we want to investigate if a similar process occurs in methanogens. So my job is to study whether or not lower bases being changed from the native lower base in methanogens has any rate on which methanogens can produce methane. If we can find a way to control methane production, perhaps we can take steps towards lowering our environmental impact by reducing greenhouse gas emissions.